All right, so a couple of things before I start and before I forget. First off, you are going to need to do some things in the next 6 days. Okay, you got 6 days to get this stuff done. First, you have to finish your Starbucks lab that you got yesterday in class. Okay, that needs to be done because it is due the Tuesday that we come back. What is that? 29, I think. Yep, that's 29. Okay. Second, most importantly, you will have to do an online formative on its learning over this weekend. Okay. There are 4 questions on its learning. You get 3 chances to get it done. Okay. So after your 3rd attempt, then we'll take the best of the scores then. So if you get 4 out of 4 the first time, you don't have to do it a second or a 3rd time. Okay? Third, you have to watch a 13-minute video and take notes on 3.5 solving exponential equations. And then I have a note sheet that goes along with that that we'll hand out later. Okay? So you've got that, those 2 things to do, or those 3 things to do, and yeah. So it's not like we're asking for a ton of stuff for you to do over the weekend. Probably not even. Yeah. Okay? Depending on how far along you are on the Starbucks lab. Okay? Alright? So, today we're going to be on that, what do you call this, cream-colored note sheet here in class. Okay? So, solve the following exponential equations without the use of a calculator. This doesn't seem to be on here. Hold on.
That's the first one. That's the one.
I know, I just gotta get to it.
You passed it.
Graphs of logarithms. This one, here it is. There we are. All right, solving simple logarithmic equations. That sounds like a better start. Solve for x. Okay, so remember that in a logarithmic equation, when we've got log with a base of an argument equals an exponent, that changes over into be the base to an exponent equals what's called the argument. Okay? If we don't see a base, we assume that it is base 10. In number 1, there is no base written. In number 2, there's a base of 2. Okay? So, when there isn't anything written like in number 1, we assume that that is base 10. So this really is 10 to the negative 2 power equals x. If I change forms with it, to solve equations, you're always going to be changing forms. If it's in exponential form to solve it, you put it in logarithmic form. If it's in logarithmic form, you change it to exponential form to solve it. Okay? So 10 to the negative 2 power is 1 over 100. Number 2, what's x? I promise it is not 64. I promise that it's 16. 2 to the 4th power equals x, which makes x be 16. To the 4th is 16. 4 squared is 64. Actually, 4 squared is 16 too. 4 cubed is 64. Okay. Natural log of x equals 3. What does that one change over into be? What does that one change over to be? No. E to the third equals x, right? And for us, we would just leave it because we're exact type people. We would just leave it as e cubed. Okay? I would not there, since we are saying that this is without a calculator, I would not expect you to do 2.7192818 to the third power. Okay? That would just be flat out mean. Okay? Number 4. What do we get there for number 4 for x? Square root of 10? Exponents of 1/2 or fractional exponents have the numerator in the fraction is the exponent. The base of the fraction is the index. So an index of 2 is square root. Love it. Okay? All right. So here again, we recall that y to the bx, or y equals b to the x power, and y equals log base b of x are inverse functions. Okay? They are inverse functions. Y to the bx power, okay, that's going to be a, and I'll put this one here in, we'll put it in green, okay. Y to the bx power, what kind of a function is this? Exponential. Depending upon the size of b is going to depend on if it's exponential growth or if it's exponential decay, correct? Okay? So we're going to assume that we're growing. We'll just assume that for right now. Okay? So what would the domain of that function be? What x values can I put into that function and get a result out? Yes, ma'am. It is all real numbers. I can put in any x value into that function and I can get out an answer. Okay? Whether or not b is between 0 and 1, or if it's greater than 1. Okay? What is the range of that function? What are my outcomes, outputs, if you will? What do you got? What's greater than 0? Y is greater than 0. Can it be equal to 0? No, because what is y equals 0 in this basic function? My ha. Actually, tap the brakes. Let me... Okay, there we go. What is the y-intercept of that function? What do you got? 0, 1. Everybody agree with everything said there so far? Huh? Now, if it's going to be an inverse function, what's going to happen is I'm going to switch my x and my y values. That's what the definition of an inverse function is. You dealt with that in Algebra 2. Okay? So I switch my x and my y's. So if these two functions, and I'll go over here now in blue, if blue and green are inverse functions, and domain is x's, range is y's, without even looking at anything, what is the domain of my blue function? What is the range of my blue function? Knowing the fact that inverses switch x and y. So my domain becomes x is greater than 0. I don't think we have any. Okay. And my range? All real numbers. If I switch x and y, my horizontal asymptote now becomes a vertical asymptote. So what would the vertical asymptote be? X equals 0. Instead of having a y-intercept, I would now have an x-intercept where? At 1, 0? Okay, so there is now my y, or my vertical asymptote. Here is now my x-intercept. Let me move this over to, oops, I guess I can't move that over to the other side. I guess I've got to erase the dot first, and then I've got to put it in here, and then I got to put it in there, and I got to put it there. That looks good. Okay, and so then now my function is going to come up and go like that. Because if you think about it, if I put in this point right here, that would be the point 1, comma b. Correct? Okay. Which means then that I would have to go over here to the point b, comma 1. We could do that for the point 2, comma b squared. Would become the point b squared, comma 2. So that is the graph of a logarithmic function. Okay. So we have two special bases. Log base 10 and log base e. So we've got y equals log of x, or log base 10 of x, one and the same. Okay. So that one is going to come up from here and go through like that. Right? What are some of the points that it is going to go through? One comma 0. Yeah. Now, if we think about the point 1 comma 0, that would be like saying 0 equals log base 10 of 1, right? Logs find exponents. What exponent do I have to put onto 10 to get 1? 0. So that's why we go through 1 comma 0. Okay. What would another point be that one goes through? Or the next integer point that it would go through? Comma what? 10 comma 1. Following the same logic, what exponent do I have to put onto 10 to get 1? 1. Or, excuse me, what exponent do I have to put onto 10 to get 10? Excuse me, I said that wrong. Exponent do I have to put on 10 to get 10? 1. What would another point that it would go through? Comma 2. Another one. 1,000 comma 3. Love it. Another one. Natural log. Natural log of x. Going to come up through here. Oops, we forgot to put in our vertical asymptotes. What are some of the points that one goes through? Let's label some points. What? 1 comma 0. What's another one? Comma what? Comma what? How about E comma 1? Which is 2.718 comma 1-ish, somewhere in that range. The next one. E squared comma 2. Next one. E cubed comma 3, and so on and so forth. Yep. Love it. Okay? Questions on that stuff? Oops. Alright, so we are now on the back side of that cream colored sheet. Okay? Properties of logs. So first off, we need to let B, U, and V be positive real numbers with B not equal to 1, and C can be any real number. Yeah? So we need those conditions first. Okay, so basically what that is saying is U and V, which you'll see, as you can see underneath here. Okay, so when we're dealing with that, we want U and V to be any positive real number. B, your base, can't be equal to 1 because that's the rule of logarithms. The base cannot be equal to 1, and the base should also be positive. Okay? So, when we have these, we've got these three wonderful rules. The first rule is called the product rule. And the product rule says that if I am taking the log of a product, so I'm taking two things and I'm multiplying it together, I'm taking 8 things and I'm multiplying it together, I can split that up and that can become log base B of U plus log base B of V. Okay? I can split those up. Now you may be asking yourself, why would we ever do such a thing? Well, I can tell you that sometimes it creates whole numbers. Okay? It makes things simpler. It makes things easier. Okay? Now, all of these properties work both directions. So you can expand if you are going to the right. You're expanding, you're making your logs get bigger and bigger and bigger. Or you can condense if you're working to the left, where you take this long string of multiple logs and you condense it down into one log, provided that they all have the same base. Okay? Quotient rule, then, is you take the log base B of U and you subtract the log base B of V. Log base B of V is kind of hard to say. Luckily, I've said it before. Okay? Power rule is awesome because the power rule allows you to take an exponent that you may have in your argument and you can slap it out in front. So you get C times log base B of U. And then the last one that we have is just the change of base formula, which says that log base B of U is really log of U divided by log of B, or it's the natural log of U divided by the natural log of B. That allows us to get common bases and allows us to find decimal equivalents of what those are. Okay? Any questions on those 4 wonderful properties? Okay? All right. So, expanding logarithms with product, quotients, and powers. Okay? So, if I am expanding this logarithm, what first I would do is it would become log of 100 plus log of x plus log of y to the 5th power. because I'm multiplying three things together, I can break that up into 3 logs. Tap the brakes, haven't gotten there yet.
Do you know what I'm going to say?
Yes. Okay?
I'm not
All right? So that is applying which of the properties? That's the product rule. Okay? Now, you would go forward and you would apply a product rule again, maybe, or a quotient rule, or a power rule if you need to. Okay? Can I apply a power rule to any of those? Which one? The last one. So this one becomes, really, it's plus 5 logs of y. Right? Okay? Then you say to yourself, self, are there any logs that I can simplify? To what? Which one? 2. Log of 100 is 2. What exponent do I put on 10 to get 100? 2. So the final answer here, when it's all expanded, is going to be 2 plus log of x plus 5 logs of y. Let me guess, it was either the last one or the first one? With both? No. Okay? And that would be the expanded form of now, condensing, which would be the next ones at the bottom there, okay? Condensing, you would start here in maroon, and we would ask you to work backwards and get to the black. Okay? So expanding takes it from black to maroon. Condensing takes it from maroon to black. Okay? What I would like you to do now is I would like you to do numbers 2, 3, and 4 on the expanding. We'll take them. I'll give you 5 minutes to do the expanding ones. Okay, so I would do this one, quick spot check on this one. I would go here, the natural log of x squared minus the natural log of y cubed, right? And then that would become here 3 natural logs of x. Oops, nope, I lied. That's 2 natural logs of x. Minus 3 natural logs of y. Yes? Boom, done. Love it. Okay? This one. Oh, there's a lot of stuff going on here. Woo, mama. Log of the cube root of x plus log of y squared, right? Minus log of 10 minus log of z. Why is it a minus log of z and not a plus log of z? But that should make it plus, though. Okay, so if we put it in parentheses, we go one more step above.
Well, I didn't. I used to more simplified than that, but we're not there.
Like that?
Yeah. That's
Which that makes it a double minus then, right?
What do you mean it's double?
Minus and minus, right here.
Oh.
Yep, minus and minus.
So it's okay.
Okay,
So you're saying
right?
mine was
Okay. So the way I go about thinking of this, and I'm a little different than most people, I get it. Okay? Anything that goes on is on when you got a big long fraction like that. Anything that's in the numerator on top, that's a plus. Anything in the bottom is a minus. Okay? Plus on top, minus on the bottom. Yep. Oh, love the 1/3. Yes. Yes. So this one becomes 1/3 log of x.
Wait.
Well, yeah, I'm not done yet. Plus 2 logs of y. minus log z, and then minus 1. I'd actually kind of almost prefer it as minus 1 first, and then minus log z, so that you don't get confused with that minus 1 in with the z, because it's really out of the z. Okay. Ideally, you'd put the negative 1 out first. So you'd go negative 1 plus 1/3 log x plus, yes ma'am.
So you know how these are variables right now?
Love it.
Are we ever going to have to solve it with actual?
Oh, yeah. Giddy up. Guess what you've got to do this weekend? With numbers. This one. Okay? So then here, this would be the natural log of the square root of x plus 4, and then minus the natural log of z to the 5th. So then I would write that as 1/2 the natural log, and I would put x plus 4 in a set of parentheses. I cannot just go natural log of x then plus 4 without the parentheses, because that means then that somewhere you had e to the 4th power. There. Gotta have parentheses around the x plus 4. Minus 5 natural logs of z.
And that's like as simplified as you can.
That is as simplified as you can get it. Or as expanded as you can get it.
Yeah.
Because that's what we're doing.
Yeah.
Yep. Yep. Condensing now we're going to go backwards. Okay? So this first one would become log of x to the 1/2 power minus log of y cubed. So first we apply the power property and put that exponent, that coefficient, back into the exponent spot. Because it's subtraction then, this would become log, pardon me. This would become log of x to the 1/2 power over y cubed, which then I could write that nice and pretty as the log of the square root of x over y cubed. The parentheses there wouldn't matter. That's a you, not a me. But if you don't write it all out, then I can't fix it if we, you know what I mean? If this were like a formative next week, or the online format, tough to do on the online formative, but yeah. Okay? What was that?
Oh, it's number 1.
It's the one on yours, but it used to be 5 on mine.
Oh.
Because the 4 that we just did were. Okay? So now do the next 3. To make your lives a little simpler, what if I wrote it like this? Would it be the exact same problem? Oops, I forgot the 3.
Yeah.
My big old head's in the way. What if I wrote it like that? Is that the same problem? Now, why are you confused?
I'm on number 4.
Oh. Okay. Because then this becomes that, which becomes that. Natural log of 2 over xy cubed. Yours, I think it's on your sheet, it was, this went back to a 1, this went to a 2. What's up? Back to this one? Do you agree with this first blue line?
Yes.
How I factored out a -1 from here. Yes? Okay, so then this becomes this, right? So if this were just my problem, natural log of x plus 3 natural logs of y, that would condense down to the natural log of xy cubed. Right?
It'd be wrong to just put
If you
2 over
Oh yeah. Oh yeah.
Yeah.
Oh yeah. How many fractions do I like? 1. Yeah. Yeah, you got 2. Yeah. Yeah. Okay. So then this is really the natural log of x to the 5th plus the natural log of y squared minus the natural log of the square root of z. So that would condense into be the natural log of x to the 5th y squared all over the square root of z. So this to me would be the log of the cube root of 5x. Do you agree with that part for this first one?
Oh.
Yes?
Yes.
Then I would say that this would be plus the log of 9. Where did I get plus log of 9 from? 3 squared. Okay? Minus the log of y to the 4th power.
Why did you put log of 9 second?
Does order matter in addition? No, it doesn't. So we could have put it way out in front, too. Okay? The first two condense to be log of 9 times the cube root of 5x. You throw in the minus log of y to the 4th power, and that becomes the log of 9 times the cube root of 5x all over y to the 4th power. Yes, ma'am.
You see how you like well, I got the bottom guys.
No. Because you're not subtracting that one. Because in order for it to be yours, it would have to be that. It would have to be subtracting that whole thing. But it's not, so you gotta go with that. Okay? It's kind of like one of those order of operations type things. Okay? Change of base formula. You guys have used change of base formula before. Okay? It's on calculators all over the place. Okay? Log base 3 of 8. Okay? So then this would be log of 8 divided by log of 3, and you would get a number close to 2. On log 8, oops, not 9, log 8 by log 3, and so on and so forth. Okay? Again, hold on, tap the brakes as I know that I'm over by 25 seconds. Okay, but this is important. Eyes and ears on me. So, this weekend, finish the Starbucks lab. Do your online formative, watch the video, and then do the note sheet. On your way out, you have a pink note sheet right here that you need to pick up